we'll look at the method of integration by substitution. So here we have a product of two functions here, and notice one of them has a higher degree than the other one. So what we do in these problems is we let that one equal u, and this one here may turn out to be the derivative of u with respect to x, so du by dx. So let's take a look. So we'll let u equal x squared plus 3x, and if we differentiate that function with respect to x, we will get 2x plus 3, which is in fact that term there. So now we can rewrite this problem here as u to the power of 4, and 2x plus 3 was du dx, and we're integrating with respect to x. Now, this expression here will simplify to du, not because we can cancel these two terms. They are not fractions, they are not algebraic terms that can be cancelled, but that does simplify to make du, and the proof of that is in your textbook. So we end up with the integral of u to the power of 4 with respect to u. So now we increase the power on u to 5, divide by 5, then add our constant. Now the problem initially up here was in terms of x, so we can now replace u by its original value, which was x squared plus 3x. And that is the power of 5 plus c. So that is our solution. So here's a second problem. So we've got here two functions that are dividing each other. Now there is no reverse quotient rule we can use, but once again, one of these terms, this bottom one here, is a degree larger than the numerator here. So if I let this one equal u, it may turn out that this one here is its derivative. So let's take a look. So we shall let u equal the denominator, x cubed plus 2x. So if I differentiate that with respect to x, I will get 3x squared plus 2, which is in fact my value here. So we rewrite our original question as 1 on u, that term is our u value, and multiply that by this term here to replace by du dx, and we're integrating with respect to x. And as before, these two terms become du. Now if we integrate 1 on u, we get ln of mod u plus c. We then replace u by its value in terms of x, which was x cubed plus 2x. So there is our solution. Our third example, so we've got two possibilities for u, either this term here, the x, or this term here. Now, we should choose the term that is larger, and that would mean 1 take x squared will be our value of u. So we shall let u equal 1 take x squared, and therefore du by dx will become minus 2x. Now notice we don't have a minus 2x here, we have a single x. So if we rearrange this equation here to make x the subject, we get x equals negative a half du dx. And that's what we will substitute up here. So we shall rewrite the question as, well, the e to the power of u now. The x is replaced by negative a half du dx, and we're integrating with respect to x. Now the constant of negative a half we can put in front of the integral, and then we have eu and then du. Now we know if we integrate an e function, it doesn't change, so therefore we end up with eu multiplied by negative a half with a plus c. And our final step, is to replace u by 1 take x squared. So that is the technique that is known as integration by substitution.